Hey everybody, the Med School Coach content team is conducting a survey about this podcast, potential future materials, and your experience with the MCAT in general, and we'd love your feedback. Survey responses are going to be used to improve our MCAT offerings and make sure that we provide students with the most useful materials possible. The survey should take approximately 20 minutes, and the first 100 survey respondents will receive a $20 Amazon gift card via email within 72 hours of your submission. If you're not one of the first 100 to fill out the survey, you'll still receive a $5 gift card. To take the survey, go to the show notes and follow the link in the show notes. Again, the first 100 people to respond are each going to receive a $20 Amazon gift card. Welcome to this week's Short Clip Friday podcast. On Fridays, I will be posting clips from previous episodes, and the point here is just to bring you some of the highest yield topics from each podcast in order to kind of reinforce those topics. This clip is from my upcoming audio course, which I hope will be out by the summer. It covers radioactive decay. Enjoy. Radioactive decay. Radioactive decay is the spontaneous breakdown of an atomic nucleus resulting in the release of energy and matter. There are 5 different types of radioactive decay that I want to talk about. 1. Alpha decay. 2. Beta plus decay. 3. Beta minus decay, which by the way is also called positron emission. 4. Electron capture. 5. Gamma decay. I'm going to go through each of these individually and talk about what you should know about each of them for the MCAT. But before I do that, just take a second to think about all the atoms composing all the objects around you. Maybe you're driving somewhere. The steering wheel that you're grabbing is made up of atoms. Maybe you're looking at a human being. That human being is made up of atoms. And clearly, those things aren't just spontaneously breaking down in front of you. Unless, of course, you're in the Marvel universe and Thanos snapped his fingers. So while every element undergoes decay, the timescale that this decay occurs is different for each element. Some elements decay so slowly that for all intents and purposes, they don't really decay at all. For example, atoms like carbon-12 are so stable that their half-life is many, many, many times longer than the current age of the universe. Throughout this segment, just kind of keep that in mind. All atoms decay, but some decay a lot more often than others. And the ones that decay more often are the ones that you typically run into on the MCAT. Okay, so I'll start off by talking about alpha decay. Alpha decay is when an atomic nucleus emits an alpha particle and decays into a different atomic nucleus. An alpha particle is just a helium nucleus, so it's composed of 2 protons and 2 neutrons. Therefore, an alpha particle has a mass number of 4 and an atomic number of 2. So when an atom releases an alpha particle, the mass number of that atom is reduced by 4, and the atomic number of that atom is reduced by 2. For example, if uranium-238, which has 92 protons and 146 neutrons, underwent alpha decay, it would release an alpha particle. And the product of this decay would have 2 less protons and 2 less neutrons than uranium-238. Now, if I look at the periodic table, I can see that a different element has 2 less protons than uranium, and that would be thorium. And then the mass number changes by 4, so the new mass would be 234. Therefore, the product of this alpha decay would be thorium-234. So again, when an atom undergoes alpha decay, it loses 2 protons and 2 neutrons. Next is beta decay. In beta decay, a beta particle is emitted from the nucleus of an atom. The term beta particle, by the way, can either refer to an electron or a positron. An electron has no mass, but it has a -1 charge. A positron, on the other hand, is basically just a positively charged electron. In other words, it has no mass, but a +1 charge. With that said, there are 2 different types of beta decay. Beta minus decay and beta plus decay. And the difference in these two lies at which different type of beta particle is emitted, either a positron or an electron. I'll start with beta minus decay. In beta minus decay, a neutron in the nucleus of an atom is converted into a proton, and in this process, an electron is emitted. In the opposite process, beta plus decay, a proton in the nucleus of an atom is converted into a neutron, and then a positron is emitted from that atom. Just to give an example of these two cases, let's take carbon 14 and show what happens to it if it undergoes beta minus decay and then beta plus decay. When carbon 14 undergoes beta minus decay, it becomes nitrogen 14. In short, one of its neutrons is converted to a proton, so its atomic number increases by 1, and the mass number, protons plus neutrons, remains the same. On the flippity, in beta plus decay, carbon 14 is converted to boron 14. What happens here is that one of the protons in the nucleus of carbon 14 is converted into a neutron, and a positron is emitted. This decreases the atomic number of carbon 14 by 1, but keeps the mass number the same, therefore producing boron 14. Now, as a word of warning, on the MCAT, if you only encounter the term beta decay, assume that it's referring to beta minus decay unless the passage specifically says beta plus decay. So for all intents and purposes, beta decay is beta minus decay, unless specified otherwise. With that said, let's talk next about electron capture. And electron capture is basically what it sounds like. It's when an atom captures an electron. Hey, give me that shit! When an atom undergoes electron capture, the atom is taking an electron, causing a proton to be converted into a neutron. I kind of imagine in this process like an atom is taking in an electron and collides it with the proton and boom, makes a neutron. Of course, that's probably not exactly what happens, but that's how I like to think about it. Overall, this process decreases the atomic number of an atom by 1 and does not change the mass number. So electron capture and beta plus decay have the same outcome. The only difference between them is that one emits a positron, beta plus decay, and the other absorbs an electron, electron capture. Last but not least, we have gamma decay, and this one to me is the easiest. Gamma decay occurs when an electron within the nucleus moves from an unstable outer energy level to a lower inner energy level. As a result, this atom will then emit energy in the form of gamma radiation. In other words, gamma radiation is just an atom releasing electromagnetic radiation. With that said, gamma decay does not do anything to the mass number or atomic number of an atom. So, for example, let's say that carbon 14 undergoes gamma decay. The product of this decay would still be carbon 14. So, just to summarize this all, it's important to have an understanding of what's going on in these different types of decay. How many protons is a certain atom losing when it undergoes alpha decay? What about beta decay? What about gamma decay? It's really important that you know that. And then, of course, it's important that you know once an atom undergoes a certain type of decay, what product is that going to yield? These are questions that you will definitely see come up on the MCAT. So if you don't have all the information that I just went through in this audio segment memorized, get that memorized. Put it on your flashcards and go through it and make sure you understand those types of questions. MCAT Audio by Med School Coach. Eventually, once the audio course is out, it features about 400 audio clips like that. So if you enjoyed that and are taking the MCAT at the end of the summer, hopefully you will have this audio course to help you study.